Hi everyone and welcome back to Maths and Physics, Mr. Simons. Today we're looking at grade 12 analytical geometry and we're looking specifically at November 2024, question 4. Right? Now let's look at the question. Right, so question 4, as I said, get in the habit, pause, look at the question, see what you can answer. Make a note in a different color of all your errors. As we then work through the solution or see where you're not sure, see if you can follow and understand. My explanation don't make sense, leave a comment and I will see how I can assist by giving you a better explanation, right? But in the diagram, M, 1 and 3 is the center of the circle, so there's the center. Circle cuts the x-axis at N, so there. ST is a tangent to the circle at P. 3 and 9 and R, D and 1 with D greater than 0 and L lie on the circle O. L lies on the circle, O and V are the x-intercepts of PL and RL respectively. Alright, so number 1, write down the coordinates of L. Alright, determine the equation of the tangent ST at P. 4 marks. Show that the equation of the circle with M can be given by that equation there. Show that D there is 7. Calculate the size of L. And then TR is the tangent to the circle at R. Prove that PT is perpendicular to RT. Right? So I say pause, see what you can answer. Right? Let's look at the first solution. Right, 4.1, write down the coordinates of L. So we want the coordinates of L there. So we should know M is the middle, so I can use midpoint theorem to solve 1. So midpoint theorem states that x1 plus x2 over 2 equal 1. Or not midpoint theorem, the midpoint formula, y1 plus y2 over 2 equal 3. So if I put in there, x plus 3 divided by 2 must equal 1, because m is the middle, and y plus 9 divided by 2 must equal 3. So x plus 3 over 2 equal 1, 2 times 1 gives me 2. Take plus 3 across, it becomes negative 3, so 2 minus 3 would give me minus 1. There, 2 times 3 would give me 6. Right? If I take plus 9 over, 6 minus 9 gives me negative 3. So x is negative 1, 1 mark, y equal negative 3, another mark, 2 marks. Could have gone a simpler route using symmetry or the fact that it's symmetrical about m. 3 minus 1 gives me 2. 1 minus 2 would then give me negative 1. 9 minus 3 would give me 6. 3 minus 6 would then give me negative 3. Right, so that's just another way of finding the coordinates of L. Right, 4.2, determine the equation of the tangent ST in the circle at P. Right, so I've just highlighted my tangent there in red. And I've highlighted that MP there is a radius, and I should remember that tangent and radius will always meet at 90 degrees. That's tan perpendicular to radius. So they have P, I can't find the gradient of ST because I don't have another point there. So equation of the tangent, so to find the gradient, I'm going to first find the gradient of MP. And then work from the fact that they're 90 to find the gradient of ST, and from there substitute P. So if I look there, M is 1 and 3, and P is 3 over 9. So for my gradient for MP, 9 minus 3, 3 minus 1. 9 minus 3 gives me 6. 3 minus 1 gives me 2. 6 divided by 2 would give me 3. So 1 mark for that gradient. So the gradient of ST, which is the tangent, should then be flipped around. If that's 3 over 1, then the gradient of the tangent would become negative 1 over 3. 1 goes on top, 3 at the bottom, and the sign changes because when I multiply that 2, they must equal minus 1. Reason, tan perpendicular to radius. So there, another mark. I can find it two ways, y equal mx plus c, or y minus y1 equal mx minus x1. Go the first route, m is negative 1 over 3 x plus c, sub in p, 3 and 9, which is the only point on the tangent. So this states that x is 3, 1, y is 9. 3 times negative a third would give me negative 1. If I take it across, it becomes plus 1. So C equal 9 plus 1, which then gives me 10. Or on the other side, y minus y1. So y1 would be 9. X1 would be 3. Negative 1 over 3x times, that would give me negative 1 over 3x. Negative 3 times negative 1 over 3 gives me plus 1. There, if I bring minus 9 over, 1 plus 9 would then give me 10. So 1 mark there for correct substitution and 1 mark for the final answer. So hope you follow and understand so far. Let's go to the next problems. 4.3, show that the equation of the circle with center M is x squared plus y squared minus 2x minus 6y minus 30 equals 0 for 4 marks. So we know that M1 and 3 is the center. We should remember the equation is x minus a squared plus y minus b squared equal r squared. Right, but my center there, 1 and 3, so positive 1 becomes negative 1, 3 becomes negative 3. Becomes x minus 1 squared plus y minus 3 squared equal r squared. To find the value of r, I'm going to take a point, which in this case I have, which is 3 and 9. That means from M to P is a radii. So there, 3 minus 1 squared, and then 9 minus 3 squared. 9 minus 1, 2 squared would give me 4. 6 squared there gives me 24, or 6 squared 36, 36 plus 4 would give me 40. So 1 mark there for correct substitution, 1 mark for r squared. For the equation x minus 1 squared plus y minus 3 squared, and substituting 40, place of r squared, another mark. Now when we multiply out, this is where you'll forget the middle term, and this is how you end up losing marks. So x times x, x squared. For the middle term, x times minus 1 gives me minus 1x, times 2 gives me minus 2x. Negative 1 times negative 1 gives me positive 1. Y times y, y squared. Again, to get the middle term, y squared times negative 3, or y times negative 3 gives me negative 3y, times 2 gives me negative 6y. Negative times negative gives me positive. 3 times 3 would give me 9 equal 40. So that becomes x squared plus y squared minus 2x minus 6y. 1 plus 9 gives me 10. But 10 minus 40 gives me minus 30. So there, my fourth mark for correctly multiplying out and remembering middle term. The last one, no mark because it was already given. Right, 4.4. So normally when we find the equation for a circle, we will always test for 1 to 2 marks substitution into that equation. So they say show that d equals 7. So there you see r is dn1. R is on the circumference of the circle. So because it's on the circle, I can use the coordinates and substitute in the equation of the circle to find the value of d. So r dn1, so there in the place of x, x becomes d, y, there would become 1 because y is 1. So d times d, d squared. D times negative 1 times 2 would give me negative 2d. Right, negative 1 times negative 1 gives me positive 1. 1 minus 3 is 2, negative 2 squared becomes positive 4 equal 40. So I have d squared minus 2d, 1 plus 4 is 5, but 5 minus 40 gives me minus 35. So 1 mark there for correct multiplication, 1 mark here for standard form. If we factorize, d minus 7 times d plus 5, d times d is d squared, minus 7 plus 5 gives me minus 2, but minus 7 times positive 5 would give me negative 35. So d equals 7 or d equal negative 5. You can see d is in the first quadrant there, so in the first quadrant there, it should be positive. Therefore, d equal to 7. Alright, let's go to the next questions. Calculate the size of L. Alright, so now we want the size of this angle L. Alright, so assume if you look there, I have a triangle. The exterior angle of a triangle equal the sum of the two opposite interior angles. So if I find this angle, I automatically have that angle. This one also, so we always find these angles using gradient. Alright, so if I say gradient of PO from P to O would be 9 minus 3, 3 minus 1, which gives me 3. If I say 10 POV, POV, so always my angle starts from the x-axis till it makes contact with the line. Shift 10, 3 would then give me 71,565 or 71,6 degrees, right? And then if I take R and L there, I use that coordinates there. Remember L we found as minus 1 minus 3 from the previous problem. So there's 7 or minus 1, 1 minus minus 3, and then 7 minus minus 1. So that gives me 1 plus 3, which is 4. 7 plus 1 is 8. 4 over 8 simplifies to half. So tan of RVN of that line there equal half. Shift 10 half gives me 26,565 or 26,6. Right, so this angle vertically opposite there, it would become 26,6. Alright, so to get L, remember exterior angle equal the sum of the two opposite interior angles. So this is 26,6, so therefore 1,6 minus 26,6 gives me L equal to 45 degrees. So 1 there for making, using angle of inclination, tan equal 3. Getting the answer there, getting the gradient of RL, using it to get the angle, and then getting the correct answer. Alright, now let's look at the last problem. So 4.6, they say TR is a tangent to the circle at R. So there, if I draw from T to R, I have a tangent. Prove that PT is perpendicular to RT. So there's RT and there's PT. So I want to prove that there where the two lines meet, they are perpendicular. So using R and M, you see there I have M and there I have R. Alright, that's my radii. Gradient there would be 3 minus 1, 1 minus 7, which gives me 2 over negative 6, which becomes negative 1 over 3, 1 mark. So my gradient of RT should then equal 3 marks, right, if it's a tangent to the circle, because tan perpendicular to radius. Right, PT and RM automatically should be parallel to each other. Based on what we solved previously, they are 90 there at that point, and 90 plus 90 would give me 180. So if they are parallel, they have the same gradient. Right, so RM and PT have the same gradient. Now if we multiply 3 times negative 1 over 3, the 3's and 3's cancel, and I'm left with negative 1. So my gradients multiply out and they equal negative 1. It automatically means that this line PT and RT are perpendicular together to each other, meaning where they meet, they would form a 90-degree angle. Right, so I hope you understand, I hope you follow. Wish you nothing but the best. Continue practicing, become the best version of yourself. God bless. Bye.